Jonathan, and welcome to the Business of Software. This is part 3. I highly recommend that you go back and watch part 1 and 2. We're talking about designing for the future. We're talking about the state of affairs within an agile development kind of scenario, the business capability, the technical capabilities, how we design up front, how we don't. Is it emergent? Is it not? How do we deal with change? How do we deal with complexity? So in part 1, really looked at change rates, change gradient, complexity gradients. You can go ahead and watch that video there. Part 2 looked at kind of the design phase and the laws of software design, kind of looking at the box and the line and positive feedback loops or negative feedback loops, as it will. I introduced 3 acronyms, Ammerse, Brace and Surface, and you can watch that in part 2. We ended part 2 looking at time boxes, and kind of the context of that time box is quite important because it operates on a different kind of time frame than, let's say, an iteration or some kind of business increment or whatever you might have. And to explain that, I would say that if I make a decision to design something today or I design it later, we have to understand what later is in the context of things. It is quite possible that we might delay something for an iteration and say, we'll do that in the next iteration, but it's also plausible that it will go on a backlog item. It will become part of the backlog and it might sit there for a while. What is the difference, the change gradient, the complexity gradient between state A, doing it now, and B, doing it at that future date? So the time box that I'm introducing here is really based on quarters. We've been doing it all the time. There's nothing new. You can say, second quarter, third quarter. And if you're going to delay something, it is likely you will delay some, large kind of design decision for 3 months down the line, 6 months down the line. We'll do it next year. It is, possible that you'll delay a design until next week, but that's probably less likely. So really the time box heuristic is something to mention, and that is we really want to do things now. We want to design stuff. If you want to call it up front, that's fine, but we want to design something that we know about, that we have technical capability. We want to do it now, especially if it provides some kind of business capability in the long term and avoids sort of treading water and doing change upon change upon change to eventually get somewhere we already know where we're going to get to. So really the idea is that we will fight hard against putting off for tomorrow, and we'll do it now, but if we can't, then we will decide when we will do it. We will do it in the second quarter. So we really want to allocate that workload for our future selves, right? Because if we don't, the change delay between phase A and B, that could be drastically different depending on when you actually do the new design. So there's a thing called an architectural design record. We can write in trade-offs and design decisions and constraints that we had when we designed something. I highly recommend that we do that as well, that we put in the time box, that we actually say, look, the change that we would have done here would involve A and B, and now we're delaying it for the third quarter, and we suspect that there'll be more to do. You'll find somebody will come to you and say something like, can we do X? And you go, yeah, sure, we can. It'll take me like a week. And they go, oh, okay, that's good to know. Thank you. Don't do it now. We'll take care of it, like maybe in a couple of months. We'll take care of it. The problem is, during that period of time, things have happened, and now you're sitting with the kind of estimate that you gave in an entirely different universe, right? Things change. So moving to another way of thinking, I want to tackle, with each video, I want to tackle another angle to the agile software development responsibility that we have. And so in this part, I want to introduce this concept, or at least find out if the just-in-time over-engineering is a thing. Could that be a thing? And I think to better understand that, we have to understand the business and technical track and how that works. And that's what we'll do now. So the 2 tracks. Big design up front, very technically indulgent. customer first, very customer indulgent. Both has pros and cons in terms of if I design something now for the future and it works out, it was the right thing to design, then we suddenly get better business capability at that future date. If I designed it incorrectly or I designed something that wasn't used, it was a waste of time. Likewise, if I design things as we go, I might be treading water, changing things, doing it again, refactoring, reworking, changing it again, getting the same outcome. I might be treading water quite a bit, listening to various quarters, listening to various customers, and eventually moving somewhere. I might have to migrate data from one design to another, adding more workload. So there is a trade-off between designing something up front and then designing something emergent. And my question here is, why can't they both kind of exist together? We'll explore that. So this is the kind of traditional view that we can have to separate these two tracks. We can say that business is concerned with building the right product, and we can say that the technical track is concerned with building the product correctly. So this kind of idea has been around for decades, and it's very true. Technical people want technical excellence and build something quick, but with quality. Business want to do something quick, but with some kind of winning dollar tag at the end, right? They want to have a successful product that sells. Now, both of these things go hand in hand. In fact, the technical and business tracks are often working together for exactly the same goal all the time, but there are some differences. If we look at that green area there in the Venn diagram, you'll see that that would be technically the sweet spot, right? We are building the right product, we're building it correctly. And this is where Agile wants to sit, right? This is where all our methodologies and everyone with good intentions in terms of building a design, this is where they want to be. Nobody wants to go to the blue area, building the product right, design all of that part of that circle in the Venn diagram, only to cut it away completely. We don't need it. However, is big design up front the only sort of bad element to over-engineering? Probably not. Probably not. We also get over seeing or kind of a business angle to overdoing something. But let's have a look at the technical and business for a second in terms of understanding what over-engineering might be. So over-engineering, if you look at this part here, you'll see that the technical domain, the slightly grayed out area here, would be that it would be quite quick to achieve that. But right now, this is the technical domain. This is the capability of the technical things that we have in place. The business domain, this is what it requires. It might bubble over a little bit, but this is really what it requires, and there's a discrepancy between the two capabilities. The business domain requires far less than the technical domain is offering. And this is over-engineering. This is classic over-engineering. We have plugins and extensibility. We have a design that can be abstracted away. We have dependency injection on every class. Everything's fine-grained. But the business domain only requires this, right? It only requires a smaller subset of that. And the reverse of that is that the business domain requires quite a lot of stuff. It requires so much stuff, in fact, you can't keep up. And your technical ability, your technical domain doesn't have enough capabilities to drive that business forward, because business is always demanding from the tech. And in both scenarios, you've got a problem, because either the business is running late with things and a technical team is running away, just big design and doing all these things, and they're not used and we can't use them on the business domain, or it's just too costly to build something like this, so it's a waste. And on this side, you've got a huge business vision and lots of capability and vision, and you're trying to drive the business, but you don't have a suitable technical team. You don't have enough people. They're not thinking ahead. They're not building things for the future. Where we really want to be is somewhere where it's equivalent, right? Whether technical is slightly ahead or not is up for debate, of course. I'm advocating just in time. So in a sense, if we could build a technical domain that is superior to what the business needs just in time, then we might have a good balance between the two. To achieve this, we need to make use of abstractions. We need our system to be configurable and extensible. We need integrations. Our solutions, when we actually solve a problem within the code base, it needs to have longevity and so on. Dealing with complexity, dealing with change, and so on. So is it only about big design up front? I mean, are we saying that you can't design up front because it's just indulgent, right? Well, what about overreaching? So the business track can overreach. They can also build up and drum up more and more potential capabilities, markets. They want to attack a new customer or type of customer, and the technical ability is just not there. That happens too. Do we have that a name? No, we don't. So there we go. BRUP, right? So big reaching up front. Okay. So why another term? Well, it's not important. But the point is, we have a term for the technical side. We have over-engineering. We have big design up front. But we don't have anything for the over-exertion of technical vision. Of business vision. We don't have anything that says you're overreaching, or you're pushing us too hard, or you're trying to get somewhere that you're just not capable of getting. We are crawling, and you want to run. This is a different thing. So I've just brought in the word just to kind of make it very clear that it works both ways. There is a balance between the technical and the business capability. And so, as I said in the beginning, we might have different business and software architecture, but really we are after the same stuff. We want faster features and less waste and quicker delivery and, all that kind of stuff. We all want that on both sides. But, business is from a sales point of view. It's from a continuous value. Can we achieve customers? What is our churn? This is kind of the business motivation, whereas the technical is, can we deliver a quick solution next year, right, with all this growing complexity? How do we deal with change and change gradients? Now, at the moment, I feel like everything is kind of geared up towards change, and technical capability is largely being magnetized towards just a few principles and a few ways of doing things. For example, extreme programming or TDD, to be more specific, or maybe mob programming or solid design principles. These kind of things are getting high traction. They're not the only things in our community. They're not the only books that have ever been written. They're not the only ideas, yet we're sort of congregating around a very small amount of principles driving our technical capability. And it might be because it sort of makes sense to the business capability or the business people on that side of the fence. It might be the things that make the most sense between the two. Whether that's 100% correct for either side remains to be seen. But there are definitely differences between these two tracks that we should be aware of. Now, just-in-time design is kind of getting ahead of the business capability just in time. So if business wants to expand their car insurance where multiple owners on a single car, or there's multiple cars for a single owner, let's just take that scenario and say that the technical capability is not sufficient. So the technical capability might be that there's one owner for one vehicle. That was the design decision. That's how it exists. So business wants to expand how it does insurance and wants to expand it to a family plan and to various other mechanisms. And you now need to modify reports, modify emails, bulk emails, modify ownership, the relationship between owner and car. So there's a lot of technical things to do there. And let's just say you've run yourself into kind of a technical dead end because you have relied on a one-to-one mapping for all of these things. Now, whether you have built tests or TDD or ITIL or anything in that way really makes no difference. You still have to do this work, right? You still have to make changes. So now you can go off, and I'll leave it for now, you can go off and argue about what helps you make changes and certainty and all that kind of stuff. But as a result of not doing that design work for a many-to-many kind of relationship, you now are faced with having to do it now. What is in your way? Tons of reports, queries, other kinds of things, code that you have to now modify in order to get to the new business capability. So what if there was a way of saying, okay, well, we understand that at the moment it's a one-to-one relationship, the owner and the vehicle. However, we probably, right, can predict that, I mean, if this is the beginning of building this product, right, we could probably predict that come a year or 2 or 3 or 5, who knows, some point in the future, there'll probably be one owner with multiple cars. And, management might say, don't worry about it. We're not concerned with that right now. We really don't want to design this. Let's just do this quickly. We need this now. And for whatever other motivations and forces, you end up doing it a one-to-one. Right. So just in time over-engineering or step design, right? Better word, I think. So step design would be that we would do some kind of element on a many-to-many basis, but we wouldn't actually implement the whole thing. So in other words, we might design our database to be a many-to-many, but on the UI and part of our code, we will enforce a one-to-one rule. We would say an owner, and we'll have a list of cars on the owner object, and the car or vehicle, I should say, right, list of vehicles, and the list of vehicles, we can write a constraint to say if the length is 1, that's it. Right? Return. Can't be greater than 1. So if you want to add, you'll go to a UI. It'll have a single UI for a vehicle, and you will type in the vehicle singularly. You'll add. It will say owner.vehicles.add, and it'll add 1. If you try to add another, a simple constraint will say, no, you can't add number 2. Right. However, the infrastructure for the many-to-many in terms of the database, in terms of various parts of the design, are now in place. So we have built something that is kind of in the right direction, but it is not the full deal. So we haven't wasted a lot of time, but it is fundamental to us moving in that direction later. And that's the kind of idea, in a very simplistic way, the kind of notion of what a step design might look like. So step design is gathering future requirements and planning and implementing, getting feedback and repeating that process like any other design process. But of course, it is trying to do it so that you can step ahead on our time box. Remember, our time box is 3 months. So we're trying to build something that, could take a month or 2, and then we have it for our future rather than doing short, 2-week sprints and an emergent sort of design of that. So if we look at what over-engineering might be, that's that red line, we might design, and then start implementing everything and realize we're wrong, and then massive changes perhaps, and then we finally get to where we think we need to be. And over-engineering is actually a lot more squiggled at the end, right? When I was involved in waterfall projects, there'd be quite a number of that. To be honest, and to be fair, it was more integration kind of issues and testing that would be the longest duration of waterfall projects that I've been involved in. Not so much the re-engineering or the redesigning of things. That happened far less. On the emergent kind of angle that we have now, the idea is that every iteration we're going to make changes. Now, whether that goes up and we continue with the previous week's work in the same direction, or whether it modifies in some way or changes direction, that is up for debate. That depends, and it's contextual. It depends on what you're doing and how you're doing it. But there is a lot more zigzagging to this approach. There is a lot more going back, making changes, adding a feature, going back, migrating data to a new, slightly different design, moving it again, upgrading the table, doing something else, realizing there's a dead end, it just doesn't work, start again, implement something that has all those previous features of all the other iterations, and then carry on. There is a lot of that going on. Unless, of course, you are conscious of this and have some kind of design element to your iterations. There are teams that do that. There are teams, unfortunately, that just rely on the iterative approach. And that kind of emergent way treads a lot of water. You take a long time to get there with a lot of back and forth. The step design approach is trying to design in smaller blocks. Right? So when I say design, it's not necessarily design only. It's not going on UML and the output after 3 months is, just, some diagrams. That's not what it is. It is a design and implementation phase that gets you to a much more secure place in that design. So it does include coding the design. A lot of back and forth between that, but it might not be committed to the same branch. It might not be part of the same workflow that others are building little features and things on the main branch, for example, however you lay out your code repositories. But the point there is that we can have longer time to evaluate and assess the future, to build something that is just in time for when the capabilities get there, or when we require the business capabilities. So really it's a balance. In a sense, right, we talked about the business capability and the technical capability, and perhaps dividing the technical team into two is an idea. Perhaps saying that, look, we've got 5 people in the team, 2 of you are going to be concerned with the greater, architectural view of things. 2 of you are going to be concerned with getting the components and choosing the right dependencies, doing code reviews much more often than others, purely for a cohesion and that kind of point of view, thinking of ourselves as a framework on which to build, supporting the rest of the team with components and modularization that you build, and you're on a different time frame. Maybe every month you deliver something, every 3 months you deliver something. And that is towards our future ambition. And maybe the other part of the team is concerned with 1 or 2 weeks and concerned with stability and tweaks to the features, something small that can be added, some bug fixes, maybe some performance changes within those designs. So how would that look? So business delivers information to the platform team, right? The 2 on that team that's concerned with architecture and the longevity of things, and the app team a little bit close focused, right? Short-term focused. Consider the app team, and they're building smaller things and tweaking, and business can feed back into these 2 teams. Now, of course, the platform team is supporting the app team is supporting business, and so on, but there's hopefully a nice flow between these 2 teams supporting the business capability. And so it kind of looks like this. We've got a platform team, which in a sense could be a lot broader than an app team. So perhaps they're building components for the second app team. Perhaps it's something reusable across 2 teams. Right? So the platform team works on longevity. The app team works on immediate goals for business. And you can see that here. Let's have this business line going through, and we have the just-in-time engineering over here, a longer iterative process here, a different sort of time frame, and we have our short iterations of our app team. So what we have here is some immediate wins where business can say, we have a problem with X, here's a bug, this is a new export format that we need, and it can be done by the app team in shorter iterations, refining and building features and extending the platform design. This is an emergent design. But we've also got a lane running here, which is step design, supplying components, supplying the underneath platform or framework for the app team. In both cases, we're now looking at immediate wins and long-term goals, because we have 2 teams geared towards these 2 business goals, really. Okay, business needs. Okay, so if we're looking at long-term design, how do we look at this? So one way would be to say that technical capability must enable business capability. So we know that. So therefore we know that we must build something technical first. You can't go and sell a product and not have it. You want to sell something you can do. And so therefore technical capability is there, and business depends on it. So technical capability must come before the business capability. Right? So there's a dependency. There's a priority there. So if it takes long to reach the technical capability, well, that's going to adversely affect business. And just because business requires it today doesn't mean that that's technically, convenient, right, to deliver the business capability today. And if you could, it doesn't mean that it's convenient or a good thing to do in terms of the technical future of the business. Business capability done in micro increments doesn't alleviate the stress of not having the technical ability. So if you have a design in the long term, and that design, if it was designed up front, catering for that, your business would succeed in some way. Right? But because you're doing it in micro increments, the stress of changing these things towards that goal is not alleviated by doing it in small bursts, right? So if you're going to pick up paper clips, they spewed all over the floor, it doesn't really matter if you do it in shorter iterations. It doesn't matter if I say, right, okay, go, right, stop, okay, now carry on picking up. Okay, stop. Right, that doesn't help anything. What you need is a strategy. You know, somebody holding a magnet and going around picking it up, and somebody behind them, you know, dropping it into a bag. You need some kind of strategy. Somebody who's picking up immediately, somebody who's sweeping them together. You need some kind of strategy to deal with it. You don't just leave the paper clips as is and then sort of go and pick it up. Each individual picking up little bits and then stopping and then picking up. That doesn't make it any easier. Designing for the long term, business capability is the key really to enabling your business. So, you know, if you're doing micro things all the way along and you're hopefully moving in the right direction, what about the company that's leaped forward? Right? So the company that's designed something for 2 years while you're going micro and they jump forward somewhere else. Right? If they jump forward somewhere else and then you have to catch up, you're doing it in micro increments. It's not the answer to business longevity either. Designing for the future only works where there is a business technical vision. So on the other flip side, you can't design for a possible future and then it doesn't happen. And if you're not far-sighted enough, if you're too short-sighted and you can't see where it goes, whatever you're designing for the future isn't really going to matter, right? I mean, your designs are going to be wrong. Designing for the future does alleviate the stress of future change. It provides agility. It helps you fight complexity today. And if you put things in place, then later on you can fight and deal with complexity. And designing for the future is often designing the future. I mean, often you're designing a future and then it happens maybe not because it would have happened, but because you were actually in the act of designing. There is an element of that, perhaps, but too philosophical, but there you go. Let's end. We're going to talk about Ammerse in part 4. And I just want to lead you up into what Ammerse is, the mnemonic mentioned in part 2. So it is my opinion that every project has the potential to be a platform. I mean, whether this is functional programming and object-oriented or whatever your design philosophy is or paradigm you're in, what you're building is going to form part of your core, of your platform on which to build other things. And that's why I kind of look at a development team as two different swim lanes or tracks or how you want to describe that, but one that is concerned with platform and one that's concerned with business capability. And I just want to end with, you know, every project is an opportunity, right, to create a platform and build on top of to get somewhere else. It's definitely not something that you should think of as writing code that you're going to throw away and then write some code and then throw it away. You really have an opportunity to build a platform, and that platform has a future. And how you design that is really, really important. So I'm going to leave it there for today. Ammerse is a mnemonic. This is the Design Maturity Index, level 1, 2, 3, 3.1. And we'll discuss this in part 4. Thank you for watching.